If you don't like getting caught in the rain but still love a good thunderstorm, you're not alone. There's something mesmerizing about watching the sky light up and hearing the deep rumble of thunder from the safety of your home. But have you ever wondered what's really happening up there beyond the window pane when lightning flashes across the sky? Let's take a journey into the heart of a thunderstorm and uncover the electrifying science behind every bolt of lightning. When you look up and see those towering dark clouds rolling in, you're witnessing the birth of a natural powerhouse. These storm clouds, called cumulonimbus clouds, are more than just gray fluff floating overhead. They're gigantic engines of energy stretching miles into the sky, and they're the perfect setting for one of nature's most dramatic shows. Inside these clouds, the air is anything but still. Warm, moist air from the ground rushes upward in powerful updrafts, while cooler, denser air sinks back down in downdrafts. This constant churning creates a chaotic environment, almost like a giant blender in the sky. The result? A swirling, turbulent mass where temperatures and pressures are always changing, and where the stage is set for something truly electrifying. Now picture this. Within that swirling chaos, trillions of tiny water droplets and ice crystals are tossed around by the wind. Some of these droplets freeze into hailstones while others remain as supercooled water. As they're hurled around, they crash into each other at high speeds, creating a scene that's a bit like a bumper car arena, except the cars are microscopic and there are trillions of them. Every time these particles collide, they exchange tiny bits of electrical charge. Some particles lose electrons and become positively charged, while others gain electrons and become negatively charged. Over time, this constant bumping and trading of charges causes a dramatic separation of electricity within the cloud. The result? The top of the cloud becomes packed with positive charges, while the bottom fills up with negative charges. This separation is like charging up a giant battery in the sky, with invisible energy building up, just waiting to be released. The air between these regions acts as an insulator, keeping the charges apart, at least for a while. It's a giant, invisible tug of war. The tension keeps building as more and more charge piles up. Eventually, the difference in electrical potential between the cloud and the ground, or even between different parts of the cloud, becomes so great that the air can't hold it back anymore. The stage is set for a spectacular release of energy. Here's where the magic happens. When the electrical tension gets too high, a tiny channel of ionized air called a stepped leader begins to snake its way down from the cloud. It doesn't travel in a straight line. Instead, it zigzags, branching and searching for the easiest path to something with a positive charge, usually the ground or a tall object like a tree or building. This stepped leader is invisible to the naked eye, but it's the crucial first step in the birth of a lightning bolt. As the stepped leader gets closer to the ground, the electric field becomes so intense that positive charges from the ground surge upward to meet it. When they finally connect, a powerful electrical current surges along the path, creating the brilliant flash we see as lightning. This return stroke happens in a fraction of a second, but it's incredibly powerful, hotter than the surface of the sun, and carrying up to 1 billion volts of electricity. The energy released in a single lightning bolt is enough to power a small town for an instant. The air around the bolt heats up so quickly that it expands explosively, creating the thunderous sound we hear moments later. That's right, thunder is the sound of air being ripped apart by the sheer force of lightning. Lightning can strike almost anything, trees, buildings, even the ground itself. When it hits, it can cause fires, power outages, and sometimes even split trees in half. That's why it's so important to respect the power of a thunderstorm and take shelter when lightning is nearby. The safest place to be during a thunderstorm is indoors, away from windows and anything that conducts electricity, like metal pipes or electronic devices. If you're outside, avoid open fields, tall trees, and water, and never take shelter under a tree. Remember, lightning can strike miles away from the center of a storm, so if you hear thunder, you're close enough to be in danger. Scientists are still studying lightning to unlock its mysteries. We know it plays a crucial role in balancing the Earth's electrical charge and even helps create compounds like ozone in the atmosphere. Some researchers are even exploring ways to harness lightning's energy, though that's still a long way off. So next time you see a flash of lightning, you'll know there's a whole world of science happening above your head. Stay curious, stay safe, and if you want more shocking science stories, hit subscribe and spark your curiosity.